Okay, this last video, you guys, this is series parallel circuits, solving series parallel circuits. So if you have a series parallel circuit, you're going to apply both things you learned from series circuits and parallel circuits. Okay. We're going to do two different ones. The first one is going to be a series parallel circuit that has one load in series and two in parallel. Okay, this is going to be 2 ohms. This is going to be 2 ohms, and this is going to be 2 ohms. Makes it a little bit faster to solve. Okay, so in a series parallel, we're going to use some voltage here first. The remaining voltage is going to be available for this branch and for this branch, which will be the same. So the first thing we need to do is get our total resistance here for the parallel circuit, just like when we did earlier on parallel circuits. So we're going to go R1 plus R2 over R1 plus R2. Okay, don't worry about what's R1 as far as labels. All we know is that basically branch 1 is 2. Sorry, this top should be times 2 over 2 plus 2 equals 2 times 2 is 4. 2 plus 2 is 4. Divide equals 1 ohm. Okay, this part of the circuit is 1 ohm. Okay, now once I got my total resistance here, now I could add the total resistance plus my individual resistance that's in series. So that means 2 plus 1. So my total resistance is equal to 3 ohms. So if I know my total resistance and I know my total voltage, I can divide them to get my total amperage. 4 amps. So that means I have 4 amps here. So if I have 4 amps and I have a 2 ohm resistor, I can multiply these two to get my voltage drop. So my voltage drop, I'm going to call this now, I'm going to call this R1. Okay, just like that. I'll call this, I don't want to confuse you guys with this, so I'm going to erase this. So the labeling now is just for purposes of identifying voltage drops. R2, R3. Okay, so voltage drop of R1 is 4 times 2 is 8 volts. So 8 volts got used here. Okay, what's left over? Okay, well 12 minus 8 is 4. Okay, so that means that this guy's going to have 4 volts for him, and this guy's going to have 4 volts for him. Okay, now we can figure out our amperage through each one of these like we did with the parallel circuit that had nothing in front. So my voltage drop for R2, voltage drop for R3. So voltage drop is 4 volts because it's got to use it all. Okay, we could figure out our amperage, we will, but you guys know that if I have 4 volts going through this load and there's nothing left after, then it's got to use it all. So 4 volts and 4 volts. So let's figure out our amperage now. Our amperage is going to be voltage divided by resistance, 2 amps, voltage divided by resistance, 2 amps. Okay, 2 amps, so the amperage from one branch plus the amperage from the next branch should equal your total amperage, 4 amps. Okay, this is how you solve a series parallel circuit. Okay, the next video I'm going to do is going to deal with solving a series parallel circuit, but with a resistor here and a resistor back here. Okay, so that video is to come. Let me know if you guys have any questions. I hope this kind of helps. You guys can watch them over a couple times if you need to. There's so many different ways to solve this. As long as at the end, you know, your numbers add up. Okay.